In this video, I will show you how to evaluate some integrals by using some really useful shortcuts. So, shortcuts in integration. And these shortcuts are actually the result of the chain rule. So, let's have a look at some of these shortcuts. The first one is, if you want to evaluate an expression where there is a derivative of function u, so u dash of x, e to the power of the function u, x like this, dx, then it's just e ux plus a constant c. So, first important shortcut that you can use. So let's have a look at a couple of examples. Let's say I want to evaluate x e x squared. Let me put it 2x here for the moment. And I want to evaluate this integral. Obviously, the derivative of this x squared is the 2x. So it's exactly of the required form. So the answer is just e x squared plus a constant. Well, sometimes we don't have the u dash, but we have something very close to u dash. So let's say this time I have, cosine x here, e to sine x dx. Well, this time the derivative of 2 sine x is actually 2 cosine x, so not exactly the cosine x. So in this case, what we will do is we will multiply by 2 and divide by 2, like this. So put half 2 and then put the rest of the expression, 2 cosine x e to sine x dx. And now the derivative of this function is exactly this one. So the answer will be half of e to sine x plus a constant, like this. Second shortcut is if you have something of the type u dash over u that you want to integrate. Well, in this case, the integral will be ln of absolute value of x plus a constant. So that's a really useful result that will allow you to evaluate these integrals of the form u dash over u very, very quickly. So, example, we just give you an example here. Let's say we have an x squared and here x cubed plus 1 dx. I want to evaluate this integral. Now, if u is the function x cubed plus 1, its derivative is 3x squared, which we don't have exactly, but we can have 3x squared over x cubed plus 1 dx, but again, we need to put 1 over 3 at the beginning, and then that is just 1 over 3, and this now is ln of x3 plus 1 plus a constant. So really simple. Third shortcut, if you have something of the form u dash multiplied by u of x to the power of n dx, then it is u of x to the power of n plus 1 over n plus 1 plus a constant c. So this really useful shortcut too. And the way we can use that is, suppose you have, let's say, 5x to the power of 4, x5 plus 1 to the power of 7 dx. Then, clearly, if this is a u here, then this is its u dash. So, by using this shortcut, it will be u, so x5 plus 1 to the power of 8 over 8 plus a constant c. Again, perhaps if we don't have the exact derivative, then we may have to do a little bit of work. Let's say, again, I want cosine x here, and I have 2 sine x plus 1 to the power of 3 dx. Then, if you think of this as u, this is almost u dash, but not quite. So what we will do here is, again, we will multiply by 2 and divide by 2. So 2 sine x plus 1 to the power of 3 dx. Now, well, the derivative of this is exactly this. Therefore, we can say then that the answer will be half 2 sine x plus 1 to the power of 4 over 4 plus a constant, which will give us, in the end, so 1 over 8, 2 sine x plus 1 to the power of 4 plus a constant c. So, really quite simple way of integrating these functions. Okay. The fourth shortcut is involves trigonometric functions. If you have u dash and sine u dx, then it is just minus cosine u plus a constant. An example, of course, it would be just a simple example, would be 2x sine x squared dx. Now, the derivative of x squared is 2x, so this will be just minus cosine of x squared plus a constant. Same idea with the integral of something of the form u dash cosine u dx, then it will be just sine of u plus a constant. U of course being a function of x, so you can write u of x if we want, or we can just write it as it is. So an example would be, let's say cosine of x3 plus 1, and here I have x squared dx. Again, the derivative of this, not exactly this, it's actually 3x squared, so we need to introduce the 1 over 3 and 3x squared cosine x squared plus 1 dx, so x power 3 dx, and that means it will be 1 over 3 sine of x3 plus 1 plus a constant c.